So now we're dealing with the lasso problem. We're trying to solve it by using ADMM. So first thing is we need to define what's x, y, and z, right? So here we have two terms. So a better way to define it to make it solvable from ADMM is need to change the second term into like a second parameter z, and then we have such constraint that x and z, x minus z is equals to 0. So we can see that the fx right here is the first term, and the gz is the second term, and then the constraint for the constraints from x and z is x minus z equals to 0. So now we can define our big F function, which is from the definition is fx plus gz and plus y times y transpose times hxz, which is this term right here, and this is the quadratic term that also from the definition like in the ADMM. So we have this b times hz squared, hxz squared. So with this term. So first we need to minimize according only with respect to x. So we just find the derivative of such function, and that equals to 0. So eventually we'll get this term. The result is like this. And then using the using the x we get from before, we also need to minimize z also by the same method, and then we'll reach this expression where this function is called a soft threshold function, where it's defined as follow. So basically, when u is greater than lambda or smaller than minus lambda, it will be u minus lambda, and if the term is if let's say the positive part, if it's smaller than lambda, then we'll just threshold it to 0, and the whole function is like a mirror, like symmetric in definition. And the y is basically the same as previous how you update the mu itself. It's very similar. So it's defined as y plus ph, which is using the new x and new z, we'll get the new y. And we do it many iterations.